All right, so I have this simple example. This is an aggregation example just because I try to put everything on it, so I figured why not just have it be aggregation as well. So we have a class that has it's an address class, so you create an address object, and the address has a city, a state, and a zip, and they're all strings, okay? And so the constructor is going to go ahead and set all of those fields. And then we have a toString, and the toString is just going to return those fields because they're all strings and we don't have any formatting really to do with it. It's just going to put them with commas between them. Okay. And then we have an equals field. And we didn't do this quite as much, so I wanted to make sure I had an example of this time. So really you can name this whatever you want, but in order to compare two objects, you need to have the object you're calling the equals method on, and then an object you're passing in. So whatever object you pass in for the address will go into obj2 for object 2, just keeping it generic. You could call it like A2 if you wanted to for the second address. But I did a little different. I created a status variable called, or I created a variable called status, and I set it at false. It's a Boolean variable. Then I wanted to do this comparison of all the different things. So not only do you have to have the same street, but it has to be in the same city and the same state and the same zip. Okay, I mean, probably you don't need city if you have zip, but I mean, we'll just might as well do everything. So we're checking everything. Because they're strings, you have to use the equals method on each one of them. And so you do need to make sure that when you're using the equals method, you do put that you're working with the second object field when you're comparing it inside the parentheses of the argument. And then if all of those are true, then I did the status is true. And I didn't put any curly braces because even though I have a really long if statement, there's only one statement under there to set that at true. And then you see that I don't have an else to set the status at false. And that's because I already set it at false up here. So because I already have it set at false, the only way it'll get set as true is if this matches. And so if this matches, it'll get set at true. Otherwise, it'll stay false. So I figured that was kind of redundant, and I didn't need to put that if I just set that variable at false. So I liked kind of condensing them that way, but there's multiple ways to do this. Does anyone have any questions about that? Does that seem okay? Pretty easy to follow? Okay, so we can create an address object. And so over here, I created two address objects. I called the first one A1 and the second one A2. And I just put some data in there, some made up data. Okay, so now comes the fun part. I can have a person. And a person, we're just going to say it has a last name and first name. I know that it has, person has all kind of other properties that you could add to it. But we're also going to put their address. But instead of putting the address as part of the person, we put it as an object inside of the person. But we could have put, the street, the city, the state, and the zip all inside the person. But that's redundant because multiple people can live at the same address. And so if we could just have a list of all the addresses, then we wouldn't need to repeat that information, like with each person. So, if 6 people live at the same address, then if we were putting all of the address information inside the person, that would get repeated with all 6 people. Does that make sense, everybody? But if you just had one address, then you can just say all 6 of those people live at those addresses. If you do it this way, if you do aggregation. So trying to find a useful example that everyone can relate to. And I think hopefully this is relatable because you don't want that repetition of having that street, city, state, and zip all repeated for each person you have. When they all live at the same address, you could just create the address one time. And when you create the address, if you just put that address object, like let's say that they live at the first address, if you just put A1 in there for the first person, then they live at that first address. And if you put A1 for the second person, they live at that address. And so I thought it helped with redundancy to think like, okay, I don't need to put everywhere I would normally put all the address fields, like all of this. I don't need these 4 fields in here. I can just put that as an object within there, and that helps with repeating the same code over and over again. So we all know, okay, we have an address, but the address is an object within person. So object has its own fields, which are those 4 fields, the street, city, state, and zip. Okay, so I already created some addresses. And then I'm just going to go through. I do not have like setters and getters for all these fields, but I could create that. Hopefully you're okay with that, and you could do that if you wanted to do that. But here I want to talk about this because we talked about this before. This is called what we call a shallow copy. So whenever you have the constructor, these two are normal, and we've been doing that, and that's fine. But it's this one that is different that we have to think about what we want to do. So if address is an object, so that's why the data type is address. And so the object is being passed into reference or to residence, okay? It's the reference, though, of the address that you have. So if I say it's like A1 from the other file, then it's a reference to A1, okay? So when I do this, I'm doing what I call a shallow copy, and a shallow copy means that I'm referencing it, okay? So I am pointing to it, so I have the information, but if I were to make adjustments, now you have to decide if you are going to. It depends on how you're adjusting your data. Then it could possibly mess up my original object. Now, if you're doing it the typical way that you would do it, it wouldn't mess up your data, because if you were changing a person's address, like let's go back over here for a second. Let's say we create a person, right? We'll call them P1. Okay, new person. And in order to create a person, you have to have a last name. We'll call it John Doe. So we'll put John. Okay. And then you have to have an address. So let's say they live at the first address. Okay, because I have this list of addresses. I have two. So I'll just say they live at the first address. So what this is going to do is going to pass in Doe, John, and A1. And A1 is this first address here, all this information. So it's going to send that here to Doe, John, and then that address A1 is going to reference this first address, right? Okay, so it doesn't really, the way I'm doing this, it wouldn't really affect anything, and it would be fine to do a shallow copy because the way I have the program structured. So it would save space, because if you do a deep copy, where I was talking about before, if you have to copy all the values from all of those 4 fields over, then it takes up more, it's more intense, and it runs a little slower. But so you have to decide if it's worth it. You might say, like, let's just do it for everything. But maybe we don't want to do it for everything because it's more intense, right? So you have to decide if it's worth it or not. So by doing it like this, it's fine for this program. I'm going to show you how it works. And then I'll show you how you could do it the other way if you decided that you wanted to change your mind. So we have them living at address 1, but let's say that John Doe, actually, let me show you this prints. So, and then I'll print it and show you. So when you print the toString, it's going to do the first name, last name. I switched it around. It was last name, first name, but I'm printing it as first name, last name. And then I'm printing their address. Now, when I say home, home is that field up here. That is the address, right? And so remember when you say an object name, so home is an object, right? When you say an object name in a printout, it's going to print the toString for that object if it has one. And so it does have one. If you go back over here, it's this information here. So whenever I say home, it's going to print all that information, like the address. So when I go over here and I say, okay, I want to print the information about person 1, which is my John Doe and this address here, it's going to print that information for me. Okay, so John Doe, and then it prints the address. Okay, so just to kind of make sure everybody's with me, if you look at the string, it did the first name, last name with a space in between, and then I did an enter here, and then I had the address. Now, home, remember, is the address, so it printed the address. How did it know how to print the address? Because that's in the toString over here with all the commas and everything. Is everybody following that okay before I talk about this whole copying thing? Okay. So you can easily switch John Doe's address, though. Like, he doesn't have to stay at the first address. He can go to the second address, right? And then if you run it, he moves to the second address. Okay, so pretty easy. So I didn't affect anything there with the addresses. But, I can create more people too. Like, let's say I wanted to create another person, and I want this other person's going to be P2. And this is going to be Jane Doe, and they're both going to live at the same address. Okay? They're married, they live at the same address. I didn't print them both, so I don't know. Let me print them both so we can see that it's working. So so two people can live at the same address, that's fine. They both live at the same address. Okay. Then they get a divorce and Jane Doe goes and lives on a different address. That's fine too. Everybody good? So the way it's working, let's say that they decided to change the zip code on this. They relocated it and now it changed to 98. Okay. Just making stuff up. Well, that would change, the address, right? So normally if you wanted to change the address, you would change it in the address class, right? And so if the address changes somehow, then it probably should change, right? And so I think the way I have it set up really wouldn't create any problems with the shallow copy the way I have it. So doing it like this is fine. So sometimes that might be what you want to do just to save space and not have it be so it takes up memory and takes up a little bit of time. And if you do that everywhere, it just gets more cumbersome, I guess. And so you have to think if you want to do it or not. But I do want to show you how to do it. Okay, so let me do something. Let me show you what happens. But before I do that, I want to show you the equals method real quick because I didn't really get to go over that. So I showed you the equals for this. I wanted to show you the equals for this. So if you wanted to compare addresses, the address class has an equals method, right? So you can compare addresses to see if they're the same. Does that make sense to everybody? That equals method? Pretty easy. I did a little different. I was saying that I created this and I set it to false, and then that way I don't have to do an else because if this changes to true, then it's already, it has to do this to change to true, otherwise it stays false. Then here, I did the same thing. I set it the same way. I have this set to false at the beginning, and that way if it doesn't match the if, it stays false. And so I don't have to do an else and set it false if it doesn't, if I set this to false at the beginning. This one, I was thinking about it, instead of just comparing first and last name, because there are people with the same first and last name. I have a really unique name, so there probably isn't anyone. But if you have like a common name, there's probably someone else out there with the same name. So you can't just compare first and last name because you would need some identifier that's different. And if you had like social security number or something, that would be a great way to reference. Now, I am going to guess that two people don't have the same first, last name, and address. I mean, that would be really weird to have two people in the same house with the same first, last name, and address, although it could happen because sometimes you name your, like, son or daughter the same name as you, then you have to go based on middle. But let's just say that doesn't happen, okay? Because then we have to get, like, middle name or something else. But it's not as common, okay? So we are going to do also compare the address. So we added the address in there to compare the address. You're using the home object and you're calling the equals method on the home. So what'll happen is it'll pass that to this equals method to compare all of the different things because it has to compare all the fields. So you do need to have an equals over on home because it needs to know how to compare the city, state, zip, and everything to know that it's the same address. So if you have an object and it has, even if it doesn't, if it only has one, you have to tell it what fields are equal in order for it to know that the objects are the same. So because address is a city, because address is an object, you'd have to go through all the fields. But because I have this equals method, I can use that in here. And so this one isn't using, this one's using the string equals method, but this one is using the equals method that I wrote over here for those, to compare those. So it's kind of confusing which equals method is it using. And that'll make more sense when we talk about inheritance because one COSC can have an equals, another can have an equals, and it needs to know which one to use. And so we'll talk about that. But it's going to use mine that I have here. Okay? Does that make sense to everybody? Pretty easy? Okay. So I want to talk about this whole copying thing. Really, it depends on your situation. If you want to do a shallow or a deep copy, but I kind of just wanted to explain because I thought it might be confusing as to, what, how to do it, I guess. So let's say we have these people, right? And we're printing them out I want to print out the address. I'm going to do the address printout for address 1. Okay. And then I'm not worried about person 2 right now. Just going to focus on person 1. So address 1, P1, it's going to print the address. Oh, do I not have him living in that address? Okay, I don't have him living at that address. Let's do him living at the same address again. I know I moved them out. Okay, so same address, right? Okay, so let's say, for example, I open this up to be public. So I can change it because I don't have any setters to change it without, and I don't want to add my setters. So I'm just going to open it up for a second so I can show you something. I don't typically make my fields public, but for this example, I'm going to make them public. It's also good that if you know if they are public, how they're handled. So I don't think it's a bad thing. But normally my fields are private so that I don't have any issues. Okay, so I just opened these up to make them public so I can access them because I don't have any setters and I would have to create setters for everything to be able to change them if I don't make them public. Okay, so it just makes it easier for me to show you this example of what I'm doing. Okay, so if I open that up and I open this address up to public, I'm not worried about the last and first name, so I'm not going to open that up. I'm just going to leave that. And then let's say I go over here and I do this. Now that it's open, I can say person 1, home, street, equal, because it's open, I can do this. If it were private, I could do this. I'm going to put testing drive, okay, because I want to know that that's the new one, okay? Now, this was the original address, and this one is the modified address. Okay. So this was what I had originally. I changed John Doe's address to testing drive. But do you see what happened to my, this is, I shouldn't say modified, I guess. This is still the original address. This is still, when you look at it, this is still A1. Just A1 after I modified that, right? So it actually changed the address up here. It's no longer 555 Maple Lane because now A1 is testing drive. So when I modified this person's information here, I modified the original. Do you see that? This is after I changed it, but this is still the referring to A1. This is A1 and this is A1. This is just A1 after I changed it because I made it public and because I did not use the copy constructor. Does everybody see that? But as I was saying before, this is not something I would typically do. First of all, that would be private. That would be weird if I did that because what I would do if I wanted to modify the address that he lived in, I would just change, he wouldn't be A1, he would be A2, or he would be whatever one from the list. I wouldn't really be messing with the addresses the way that I just did. That isn't something that I would normally do, right? But I want to leave you open that it can, and someone could put code in there and it can happen, right? So it's something to think about, right? Okay, so I want to show you how you can stop this if you do it the copy way. Is everybody following what I just did? So, okay. And I'm not saying that the way I had it before was wrong, because I'm saying this is really unusual situation, and this isn't something that would normally happen, so this isn't something I would normally worry about, right? Okay, but if you were worried about it changing, what you would do is you would go over here, and instead of saying to reference that, what you would do here is you would say, no, I don't want to reference it. I want to create a new address object, and I want to pass in this reference here. Okay, I know it's upset with me, but I'm creating a new one, okay? And then I go over to the address and I say, okay, I'm gonna do this as 2 ways. You can do it this way, but you can also pass me an address. You can call it whatever you want. I'll just call it R for residence or A for address. And then I just say R.street, R.city, R.state, and R.zip. Okay. Now, what I did was I'm saying, if you do it this way, I think I fixed that. Okay. If you do it this way, when you pass in the address object, it's going to take that reference, okay, and send that reference here, copy out all of the field information and put it in here as a new object, okay? So it's not referencing the old one. That keeps it from referencing the old one. This is called a deep copy. Is it necessary in this example? Probably not. Does it take up more room? Yes. Okay, so you have to decide if it's worth it. What will it do differently? Well, if I were to do something kind of crazy like this, that I probably wouldn't do. Do you see how it didn't change? Do you see how this changed? This stayed the same, but this changed? If you remember before, I just took a screenshot or something before, but this was changing to testing drive here, the street, before I did that copy. But now because I copied it and I messed with his information, I didn't affect the original. I affected his address, but not the original address. Now, this is kind of a crazy example because, again, if he had moved to a different address, I would have just selected a different address object and not have messed with his address from within his object like that. So that's not something, again, I would do really, because that kind of messes up the data in the system. So that's why, again, we make things private, because we don't want people doing what I just did. But I'm just trying to show you, that was an easy way to show you that depending on your situation, you may want to think about doing a deep copy if you think that something could get messed up like that, because it keeps it so things like that won't happen. But if you don't need it, it is extra space you're taking up. Does that make sense to everybody? So if it's not necessary, maybe just do a shallow copy. If you feel like it's going to be a problem, then do the deep copy, and then you're sure, right? Okay. Go with the side of caution and just do a deep copy, I guess. Okay, does that make sense? Are you all following? Does that kind of help? I couldn't think of like a simple example, but yet something you would actually do. I'm sorry, but I wouldn't normally do this because I don't like to open up my fields to be public, and I wouldn't do something like this. So that wouldn't be something that I would really do. But I just wanted to show you that in case you needed an example to go by based on. Okay. All right, so I'm going to post this in Canvas for you, and then you can see the difference between shallow and deep. You can play around with it if you want to. And I have it in the video if you want to go back and rewatch that little part about shallow and deep copy. But I have a more advanced project to show you. Is everybody okay with this one? I tried to get a basic one because the next one's a little more advanced. Okay, so let me pull up the CML diagram I have. I think I want to start with. First, we have a car. Okay, that's pretty easy. So we have a car. We have a meter that's going to have the number of minutes. We have a police officer, and the police officer is going to patrol. And if you did not pay for the number of minutes that you're supposed to pay for, then you're going to get a ticket. Okay, so it has quite a few classes, but the parked car is pretty easy to understand because we just have some basic things. Make, model, color, and license number are all strings. The minutes parked is an integer. That's going to tell the police officer if they need to write a ticket. I'm not worried about the copy constructor. We're going to do one without it and then one with it. We'll talk about that. That's why there's two constructors there. One does everything individually and one does the copy, the deep copy we're just talking about. And then we have a two-string. I don't believe that we have equals on here, but that last example I gave you had equals in case you wanted to reference that. Okay, so let me go to my project. This one, parked car. Okay, so it looks like this. Again, I try to make all of my fields private so that they cannot be changed the way I just showed you before. But it keeps things a little more secure. So we have all of these fields. We have this constructor that sets all the fields. I do not have the copy constructor in this one. I'll show you that in the next one. This is a shallow copy. Okay. And we have all the setters in case you need more examples of setters. I think we've done that quite a bit though, so hopefully you're okay with that. But I know we haven't been doing it recently, so make sure you don't forget about the setters. But setters for everything, getters for everything. Okay. And then a toString just prints everything out. The formatting, your book likes to use this way. You can do whatever way is convenient, makes sense to you. But it's just going to print everything, all the fields that you have for the car. Is everybody okay with this? All right, perfect. So let me show you the next one. So that was the car. Then we have the police officer. The police officer has a name and a badge number. Don't worry about the copy constructor. And then it also has an interesting method, has a constructor that's going to set the name and the badge. It has a patrol method. The patrol is going to use the park car, the meter, and then they're going to issue a parking ticket. Okay. So, and then the toString is just going to print out the information about the police officer. So just in a general sense, let's take a look at what that looks like. So police officer, name and badge should be pretty easy. The constructor sets the name and badge. There's setters and getters for that information about the police officer. This one is a little tricky, so I think we'll come back to it. But basically, we pass in the parked car and the parking meter. So we can pass in the object, so we have all the information about the car and all the information about the parking meter. We haven't talked about the parking meter yet, so let's take a look at that one. And then we'll come back to this. Okay, so I have parking meter. The parking meter is pretty easy. It just has the minutes purchased. And then you can set the minutes purchased in the constructor. You can ask for that information or you can change that information. If you want to purchase more minutes, you can do that. And then you can ask how many minutes you purchased with the get minutes purchased. Okay, so let's take a look at that file. Okay, so the parking meter has the minutes purchased. It has the constructor that sets the minutes purchased. It has a setter and it has a getter, so it's pretty easy. Okay, so far we have 3 objects. We have a car, a police officer, and a parking meter. Is everybody with me? Okay. So we have a parking ticket, and the parking ticket uses aggregation because the parking ticket has the police officer's information and the car information as part of it, okay? And so if you're looking at it, this is our UML diagram for how this is laid out. So the parking ticket has the car, and the car is an object, because remember the car has all this information with it, okay? So the car is an object, and then we have the police officer information up there. So the police officer is an object as well. So again, aggregation because the car object is within the parking ticket object and the police officer is an object within the parking ticket object. Okay. But then you also have some extra information. You have the fine, how many minutes, and then, you know, just like how much you're going to charge for extra parking and everything. Okay. Again, don't worry about the copy constructor. But the parking ticket, you're going to need to have a car whenever you create it. You're going to need to have an officer and the number of minutes. Okay. So there's a calculate fine. The calculate fine is going to figure out how much you owe based on how many minutes you purchased. And then how many you parked for. Okay. Did you have a question?
Just to make sure aggregation is where you bring more than one object in one class.
It's where you have an object and one of the fields for that object is an object itself. Does that make sense? Okay, it's when a field is an object. Okay. Yeah, so the parking ticket is an object, and then within the parking ticket, the field is a car, and the car is an object. And then you have a police officer to object. But you can also have other fields that aren't objects, but at least one of those fields is an object. That then, because then you have another whole class that has, so like this is this field. Like it's just telling the parking ticket all about the car. So again, you could think like, I could have put all that car information up in the parking ticket, but you know, it's redundant because this isn't as great as the last example, but that car can get like multiple parking tickets and you don't want to keep repeating that information about the car. The last example I had was a little better because I was saying you had a person and a person has an address. So address was actually a field, an object field within a person. And you can have a list of addresses, which would be objects, and a list of people, which are objects. And those people had the address object within it. And so you can have like 10 people living at the same address, and you're not repeating that address information for each person because you're just saying they live at this address that was an object, and it references that. It helps. Instead of putting everything in one, it keeps the redundancy down of and mistakes and of having like, okay, I have to have all this police officer information here. Whereas if you had an object, that police officer can write many tickets. Because if you think about it, a police officer, if they're going around patrolling cars, they probably give out multiple tickets per day. So if you have to, I know it's only a name and a badge number, but it's a little easier. Let's imagine there were more, because I know 2 fields isn't that much. But if you had a bunch of information about the police officer, all their contact information or whatever on there, then when you connect it and you say it's this police officer, you don't have to keep repeating that on every single ticket that they issue. And same thing about the car. The car is a little better because it has more fields. But normally a car doesn't get multiple tickets, although it can happen, then you don't have to repeat that car information for every ticket that they got. Like if they're always constantly illegally parking and getting tickets, then that car information isn't repeated. Okay. All right. So if you take a look at NetBeans, this parking ticket one, and actually, yeah, let's take a look at it. We have a parked car. See, remember, this is the aggregation part because that car is an object itself. So that's what that's what the term aggregation is, that this field is an object. And so, you have to go to this class to find out all of the fields and everything that go with that. And then this field is also an object. So we have 2 things. We don't have to have 2, but just one makes the aggregation. But we have 2. And then these are just basic fields. Okay. This is going to be calculated how many minutes you were illegally parked. And then we just have some constants that, like, how much do you want to charge them per hour? Okay. So this is doing what we were talking about before. It's doing a shallow copy. So we just talked about that in that person and address one. A shallow copy means it's referencing the old, like if you're passing in the car, it's referencing the car. We're not making changes to the car in this file, but if we were, we would be changing the original car. And so you just have to be aware of that. But this is just a shallow copy. And the way I have it works perfectly fine. We don't need to make it a deep copy, but I'll show you how to do that in case you want to, in case it would cause issues in the future. So these 2 are both shallow copies. They're just referencing the objects because these are both objects. So, and then this is just the minutes. That's not an object. This is going to call the calculate fine method. So that's separate. That's down here. And the calculate fine is kind of a drawn out process for figuring out what's going on. So before we do that, I would like to go to the main method first and take a look at just how we create the objects. So if you look, the first item that was created, the first object is a car. So it's just called car, okay? And it's a Volkswagen 1972 red. It has a license plate number. and it was parked for 200 minutes. Is everybody okay with that? Bless you. So this is created if you go to the parked car, there's a constructor that gets all that information and sets everything for that car. Okay. Then I have a parking meter. The parking meter only has one thing. It's how many minutes you were parked for. So if we paid for 200, oh wait, I don't have this right. Sorry. Just ignore that. I was playing with it. Okay. I don't have this right either. So I changed the numbers a bit. So let's just condense this and we can play with those numbers to see what we get. Okay. So we have a parking meter that has 100 minutes. Okay. But you were parked for 200. So that's a problem. Okay. So you only paid for 100. So if I go to the parking meter, it's going to go ahead and use the constructor to set the 100 minutes for the parking meter. And then the police officer has a name and a badge number. And so if you go over to the police officer, we have a name and a badge number. So far so good. Those are my 3 objects that I need. So I have 3. You need a parked car, a meter, and an officer. Okay, so if I want to know if the officer's, patrolling and looking at all the cars, I'm going to say which officer is patrolling. So I'm going to go ahead and take this officer I have here, this one here, which is Joe Friday. Okay, he's going to do the patrol method. So I'm going to have to go to the police officer and get the patrol method and look at that in just a second. But what do I need to do the patrol method? I need a car and a meter because I need to know how long they were parked. Okay. So if I go to the police officer and I look for patrol, I'm passing in a car and a meter. Okay. So go to the police officer and I look for patrol. Okay. Now I'm passing in a car and a meter, right? Okay. Now, if first we have this parking ticket, the parking ticket's the other object that we were talking about, right? So we create a parking ticket. We set it at null, okay? Because at the end, if it's still null, we don't need to write a ticket. We don't have a ticket. So if this is still null at the end, then we don't have a ticket and we don't have to do anything. Okay, so we're gonna have to check how many minutes did they pay for and how many minutes did they park, okay? So if we go here to figure out the legal minutes, we're gonna take the car that was passed in, okay, and get the minutes parked from the car. Somebody with me? So that's how many minutes the car was parked. Then I'm gonna get the meter that was passed in and get how many minutes were purchased from there. And if I subtract how many minutes you parked minus how many minutes you purchased, that'll tell me how many illegal minutes you were parked there. Okay. Now, if the legal minutes is greater than 0, meaning you parked longer than you paid for, okay, then we're going to go ahead and issue a ticket. What happens if you didn't? If it's 0 or if it's not greater than 0, okay? Well, then it's going to return the ticket. And if it returns the ticket and it's still null, and I want to show you something. I'll go back over here. Down here, it says if the ticket's not null, go ahead and print the ticket information. But if the ticket is null, then it would end up here and it would say no crimes committed. So if it comes back here and it is null, meaning it never wrote a ticket, then it would print no crimes committed. Okay, so back over here to the police officer. Okay, now if I do issue a ticket here, then we're going to get the part that we print the ticket. So remember here, it's going to print the ticket. When it prints the ticket, this tells it to call the toString on the ticket, right? Okay, so it's going to go and send this information to the parking ticket. So it's going to send the car because we need to know about the car, what's the license plate number and everything. This is interesting. This is whatever active object you have. So you have to look at what class you're in. So I'm in the police officer class. So that would be this would be the police officer. That's how you send the police officer because it's the active object in here. So if you want to send the police officer, So it knows that it's a police officer. This is kind of tricky because it's what the method was called on. So when you call the patrol method, you called it on a particular police officer, which is this one here, Joe Friday. So it knows that this officer is the active object because if you're in the police officer class, then you must have the police officer object. You have to call the police officer the patrol on a police officer, so that's the active object. And so this refers to the police officer. So, and then the legal minutes is what you calculated up here. So you need the car, the police officer, and again, this is referred to as this because we're in the police officer class. Otherwise, we would say, whatever it's called when we passed it in. But we didn't pass it in because we're in that class. And then the legal minutes, okay? So if I look at the parking ticket, the parking ticket is good. When you create a parking ticket, you're going to pass in the car, the police officers, and the minute. The police officer and the minute. See, this is what I was just talking about here. See this parking ticket? Car, police officer, minute. Is everybody with me? So here we have the parking ticket, car, police officer, minute. Okay. So car just sets the car, officer, minute, and then it also calls a calculate fine. How does it know that we have a fine? Because it would have been null if it, if you issue the ticket, the only way to issue the ticket is if you were legally parked, that's when it creates the new parking ticket. So it only creates a parking ticket if you were legally, otherwise it leaves it null. Okay, and it doesn't create a ticket. This, inside this if is what creates the ticket. So we know that if we got to this point, we must have a fine. So we just have to figure out what it is. Everybody following that? I know it's kind of a tough example. Okay, but if you just work through it, hopefully it's not too bad. So calculate fine comes down here. We're gonna see, how many minutes you have because it set the minutes. So when it did this part here, whatever minutes you were illegally parked, that's referred to as minutes now. Okay, so here, whatever minutes you were illegally parked, we're gonna figure out how many hours that is. Okay, so if we divide it by 60, we can figure out how many hours. This one is gonna chop it and figure out what that is as an integer. So if you were to take so here, let me just go back here real quick. You parked 200 minutes and you only paid for 100, right? Let me just run this so you can see what happens too. You overparked 100 minutes, okay? I thought I ran it. Okay, so it's gonna tell you how many minutes you parked, how many minutes you were illegally parked, and we have to figure out this fine. Okay, so that's what we're trying to do now. So we overparked by 100 minutes. So if I go back here to the calculate part here, if I pull up Notepad to kind of show you what's going on, I can say I want to take the 100 minutes because I know I did 100 because I subtracted the 200 minus 100. So if I just say, just so you remember, 200 minutes parked is what you were parked for. So 100 minutes illegal, right? Okay, so we take the 100 divided by 60, and we did 0.0 so we can get the decimal answer. Because if we just did 60, we'd have a problem, right? So we do the hours is going to equal 1.6666. Okay. All right. Then we're going to take hours as int, and we're going to make it just 1 because this is going to chop it. It doesn't round it. It just chops it. Okay. And then this is going to say, okay, if we take the hours and we subtract the hours as int, so if we took 1.66666 minus 1, is that greater than 0? It is because there's 0.66666, right? If we subtract it. So it's going to add 1 to hours as int. So then hours as int is going to become 2. Just rounding it up 1. That's what that's doing. This is rounding it up 1. So it's saying you overstayed. Instead of charging you for 0.66666, we're going to charge you for another whole hour. Does that make sense? So if you stay 1 extra minute, you get charged another whole hour. It's expensive, right? But this is your book, 6.5. Okay, so you get charged for 2 hours instead of 1.666. Is everybody following? Okay, so this is what you're going to be charged based on the 2 hours. And then what it's going to do is it's just going to take the base fine, which is, I think, 25 something. 25 up here. The base fine is 25 and the hourly fine is 10. So it's going to take the fine. It's going to take the hours as int, which is 2. That's what I just calculated. Times the hourly fine, which is 10. So it's going to take the 2 times the 10, because hourly fine is 10, and add the fine to it. The fine is 25. So it's going to take 2 times 10 plus 25, right? Is everybody with me? And then replace it. Are y'all following? Okay. So if I take 2 times 10, I get 20, and I add 25, I get 45, right? So the fine should equal 45. Did I blow your mind, or is everybody okay? Okay. Yeah, sure. Perfect. It's up at the top. So the base fine, the fine was set at the base fine, which is up here. It's just the reason why I did it, I didn't do this actually, your book did it. The reason why they did it that way is just to give it a starting point, and then it adds on, like it adds this onto the fine so that it replaces it. And so it takes like whatever hours you parked, which is 2, times the hourly fine that's also at the top, which is 10. So it takes the 10 times the 2 hours that you parked and then adds that to the 25 base fine. So just for parking illegally, you already get the $25 fine. And then based on how long you parked, you get an hourly fine. So kind of hefty fine, but. And so what that's going to do is when it prints the ticket, so I have to go look at the toString for the ticket, it's going to print now I never do it this way, but if you like it, this is fine. It's going to print the car data, and the car is going to have, if you look at the car toString, that's what it'll print for the car. So the car is going to print all this information, right? The make, the model, the color, the license plate, the minutes parked. So when you say in here, car data, and you say car, that's all of this, right? And then when you go back here, back to my parking ticket. When you say officer, that's going to call the toString for the officer, which would be all of this. And then when you say minutes, that's just the minutes. And then fine. Now the fine is now the $45 because it got replaced. So it should say the minutes illegally parked, and that should be 100. And then it should say the fine. And it has some formatting in here to have it like 2 decimal places with the dollar sign. The fine should be the $45. So if I run it, it gives you the car information that came from the parked car class, the toString in there. This information came from the officer class. And then this was just the minutes illegally parked, which we calculated when we subtracted 200 from 100, 100 from 200. And then this was what we just calculated, the $45. But if you, just to show you, if you paid for what you actually had, like if you paid for 100 and you had 100, then you shouldn't get a ticket. So if you run it, what's going to happen is this is in here. Oh, when the officer does it, when it subtracts them, it'll be 100 minus 100. And so this won't be greater than 0. And so then it'll say return ticket, and ticket will stay null. And then if it comes back over here, if ticket is not equal to null, print it, but otherwise no crime. So it should say no crimes committed because it is equal to null. And so it doesn't give you any information about the car or anything. It just says, because this only prints the ticket whenever there's a ticket. Now, if you wanted to, you could do a printout of like the car and everything, but if there's no, you could just say that nothing happened, so you don't need that information. Okay. And then, of course, if you pay for more than you park, that's also going to be okay. Like if you pay for a parking meter, if we do it the opposite way, if we pay for 200 minutes and we only stay for 100, then still same thing. Right? And if you, let's just change that. Let's say we paid for 50 and we parked for 300, then we'll get a higher bill. right? So now we have a higher fine. Just to kind of test it and show you. You should have this in the course note folder, course notes folder. And this one doesn't have the deep copy. And so the other one does. I think this problem is probably hard enough without the deep copy. I believe I have both examples on there for you. But if I don't, I will post on Canvas. But this one did not have the deep copy. It just referenced the old one. But I do have one that has it if you're interested to know how you do it. And so the difference would be that when you do the car, for example, you would need to have a constructor. We just talked about this with the address one, which is a little bit easier of an example because I don't have so many classes with as much going on. But you would just need to pass in the car, and then you would just pull out all the values for the car and put them in there. And then when you actually are doing the police officer, same thing. You would just have a copy. You would have both. You'd have the one I had before, have the copy one that pulls out all of the values and puts them in here. But when you actually have the file that is using the aggregation, which is the parking ticket, this is the one that has the aggregation, that has those two objects in it. Whenever you create it and you're passing in the reference, you create the object here. And this tells it, no, I don't want to just say, like, again, this would be the shallow copy. Okay. I don't want to just reference the car. I want to actually create a new car. And it would look like this. And how does it do it? Well, it goes to the park car class. It passes the reference of a car there. And it goes and it matches this one. It makes car 2 the reference to a car. And then it just pulls all the values out and puts them in. One by one, right? And then if you pass in all the values, it'll match this constructor. But if you pass in the car, it'll match this one and pull out all the values. So it makes this example even more complicated. Is it necessary? It depends. You have to think about really how people are going to be using it, and if there's a possibility that you might be changing something that you wanted to not get changed. And if that's a possible, then you should do a deep copy. If that's not something that's going to happen, then maybe do a shallow copy because it takes up less space. It's easier to follow. And so both are useful. Just depends on what you're doing. Okay. So this was a really tough example, probably the toughest one you have. But you do have it. It might take some following through it, maybe writing down some numbers if you're trying to actually get the fine. It's not as important that you can calculate the fine, is that you understand how the 2-string methods are working. This one doesn't have an equals, but if you wanted the equals, I would refer, I'm going to post this one on Canvas. The address one that I had, I would go to that one because I put one for both of them. I put an equals for the address, and then I put one for the person. And so I'll post that on there for you. And by the way, the version that, oh no, I have this. I can post the deep copy and the shallow copy. So you have both copies so you can see the difference. Okay, so this one was the deep copy where I created the address copy here. And I'll post the one without that, which is the shallow copy sample. So you can see the difference. Are y'all okay? Okay. Does anyone have any questions? Okay, so